Hello everyone, welcome back to our channel. So today we are going to see about how to solve the problems on a metric space. In R square, define d of x comma y is equals to mod x1 minus y1 plus x2 minus y2, where x is equals to x1 y1 and y is equals to y1 y2. So we need to prove that this d of x comma y is a metric space. So, in order to prove a metric space, d of x comma y is a metric space, we need to satisfy the four conditions as we learnt. So, we will see the conditions step by step. First, we need to write what are the given and what we need to find out. So, the given data is d of x comma y is equals to mod x1 minus y1 plus x2 minus y2, where x is equals to x1 y1, x1 comma y1 and y is equals to y1 comma y2. So the first condition is null property, positive property, which is d of x comma y is greater than or equals to 0. Here we have d of x comma y is mod if you consider this total as x. Therefore, always the mod will be greater than 0. Therefore, x1 minus y1 plus x2 minus y2 is greater than or equals to 0. If you take any numbers in it, it will be very easy. For example, let me take x1 is equals to 2, y1 is equals to 4, x2 is equals to 6 and y2 is equals to 3. Therefore, if we substitute these values, 2 minus 4 plus x2 is 6 minus y2 is 3, we need to prove this value is greater than or equals to 0. 2 minus 4 is minus 2 plus 6 minus 3 is 3. So we get 1. Therefore 1 is obviously greater than or equals to 0. Therefore we have satisfied the first property. And now the second property is null property. If x is equals to y, then d of x comma y is equals to 0. Yes, this is the condition of null property. Here in the metric space, the points to be taken as same, which is nothing but the x should be equals to y. If x is equals to 2, then y should be also equals to 2. Then only the d of x comma y is equals to 0. Therefore, we have mod x minus y1 plus x2 minus y2. So, we need to take x is equals to y. So, I am taking x1 is equals to 2 and y1 is equals to 2, x2 is equals to 3 and y2 is equals to 3. Mod x1 minus y1 is nothing but 2 minus 2 plus x2 minus y2. 3 minus 3 is equals to 0. We need to prove that. Therefore, 2 minus 2 is 0, 3 minus 3 is 0. Mod 0 is 0. Therefore, d of x comma y is equals to 0 if x is equals to y. Therefore, mod x1 minus y1 plus x2 minus y2 is equals to 0. So once see here, we got mod 2 minus 2 plus 3 minus 3, which is equals to 0. So d of x comma y is equals to 0 if x is equals to y. So we have d of x comma y is mod x1 minus y1 plus x2 minus y2, which is equals to 0. And now we need to prove the third property. The third property is symmetric property. D of x comma y is equals to d of y comma x. This is the symmetric property. In the place of x, we need to substitute y. In the place of y, we need to substitute x. So d of x comma y we had as mod x1 minus y1 plus x2 minus y2. And d of y comma x, we can write it as mod y1 minus x1 plus y2 minus x2. For example, let us take some values in it to prove d of x comma y is equals to d of y comma x. Let me take x1 is equals to 4, x2 is equals to 2, y1 is equals to 6 and y2 is equals to 3. Therefore, we get d of x comma y is equals to 4 minus 2 plus 4 minus 6, y1 is 6 and x2 is 2 minus y2 is 3. Therefore, d of x comma y, 4 minus 6 is minus 2 plus 2 minus 3 is minus 1, which is equals to minus 2 minus 1, which is minus 3. Therefore, we had mod, so we get 3. And d of y comma x, which is y1 minus x1, 6 minus 4 plus y2 minus x2, 3 minus x2 is 2. Therefore, 6 minus 4 is 2 and 3 minus 2 is 1, which is equals to 3. Mod 3 is equals to 3. So, we got d of y comma x is equals to 3, and from this 1 and 2, we can say that d of x comma y is equals to d of y comma x. So, we have proved the third property also. And now the fourth property, which is triangular or inequality property. D of x comma y should be less than or equals to d of x comma r plus d of r comma y. So here the r is nothing but we are adding and subtracting any one of the real numbers. Real numbers are nothing but the integers, rational numbers, whole numbers, natural numbers and irrational numbers. So take d of x comma y here, mod x1 minus y1 plus x2 minus y2. So for this I am adding any real number, which is nothing but we can take rational numbers, irrational numbers, whole numbers, natural numbers and integers. So I am taking the integer z here. So mod x1 minus y1, I am adding and subtracting z1. So z1 minus z1 plus x2 minus y2 plus z2 minus z2. Therefore, we can write it as x1 minus z1 plus z1 minus y1 x2 minus z2 plus z2 minus y2. So I am taking all the x terms one side. Therefore, mod x1 minus z1 plus x2 minus z2, and taking y terms to the another side, z1 minus y1 plus z2 minus y2. So if you see this one, this is in the same way of x1 minus y1 plus x2 minus y2. In the place of x1 y1, we have x1 z1. In the place of x2 y2, x2 z2. So this can be expressed as d of x comma y. Therefore, I can express it as d of x comma z plus, in the same way, we have z1 minus y1 and z2 minus y2. If you compare this one and this one. In the place of x1 we have z1 and in the place of y1 we have y1. So I can express this as d of z comma y, right? So I have proved that d of x comma y is less than or equals to d of x comma z plus d of z comma y. Because it is a triangular inequality property, we can take less than or equals to or greater than or equals to. This is how we need to solve the problems on a metric space. I hope you have understood this problem. In the next video, we are going to see a node point, and that node point is proved by a problem. Thank you all. Happy learning to you.